Hi coders, welcome to another episode of my vanilla JavaScript and HTML5 canvas animation series where we create all different kinds of interactive animated effects from scratch with no libraries using just pure vanilla JavaScript. In each tutorial, we learn a new technique while building a complete project. Feel free to code along and come up with your own variations just to practice your front-end coding skills or to show off on your personal portfolio website, GitHub or CodePen. In the next couple of videos, we will focus on game development from scratch with JavaScript. We will learn about important game development techniques such as collision detection, sprite manipulation, enemy AI, frame rate optimization, add-in sound, player input, and so on. You can see I put together a couple of quick prototypes for this video. Not all of it is finished. We will finish these when we learn about hitboxes and triggering animations with collision detection. Everything you've seen so far is basically just variations of two simple beginner level games with different skins. Space shooter and two squares with collision detection and score counter. The one you see right now was inspired by this brilliant CodePen. Link to the CodePen is in the video description below. I always like to start with just basic game skeleton and underlying logic, and then I dress it up with images and animated sprites. You can see that sprites add a lot to the game. You can completely change the theme and feel of your project by choosing the right sprite sheet. I will show you how to build all of these games from scratch in this series and how to add your own sprite sheets to make it unique. Don't forget to hit the like button if you enjoy this type of content, subscribe and click the bell icon to get notified when I release another creative coding vanilla JavaScript tutorial. On the left side you see the basic structure for the game, and on the right side I just slightly altered the functionality and added sprites. Sprite sheet is an image that combines multiple animation frames into a larger file. There is one big advantage to using sprites, especially for larger projects that use a lot of graphical resources, so basically all games. Placing all your frames into one larger image reduces the number of calls to the server and therefore reduces latency. Instead of calling the server 51 times to get all the frames for our animated character, we call it just once. For my personal projects, I usually buy sprites. They are not too expensive and there is some beautiful art available online. For this tutorial, we will just use random sprites I found on the internet. All the graphics you see in this video were used just for educational purposes and were found using Google search. I will show you how to use 4 directional sprites where we have 4 rows, up, down, left and right animation, and once we master that, we will make our player character with 8 directional sprite sheets, which can also move diagonally, top left, top right, down left and down right. CodePen can be a good place to get inspired when building a new game. I will include Chris Coyer's collection of gaming pens in the video description. CodePen usually has very simple projects, but it's interesting to see what people are able to come up with. There's hundreds of block breakers, car racers, Flappy Birds, Flappy Dinosaurs and Flappy Dogs. They have platformers, endless runners, asteroid clones and many more. All of these are quite beginner friendly to build, although some knowledge of JavaScript is needed, of course. This tutorial is not an introduction to JavaScript, but I think you can learn a lot if you just code along, even if you don't understand everything just yet. My goal with this series is to teach you the skills and techniques you need so you can build any of these from scratch and add your own sprites to create your game in any theme you want. It really is just a couple of repeating techniques, but they require some practice to master. In this tutorial, we will take a closer look at character animation from sprite sheet using just plain vanilla JavaScript, specifically using drawImage canvas method. This method is the single most important thing you need to understand if you want to animate sprites with JavaScript, and we will go through it in detail. We will then replicate and randomize that same character with ESX classes to show you how to generate groups of NPCs or enemies for isometric top-down games. Animating sprites with JavaScript is very simple if you understand the basic rules. It also gives you much more flexibility than animating with CSS keyframes like we did in the previous video. We will go through JavaScript sprite sheet animation step by step in detail now, building this animated background with randomized walking characters. Let's start. We will work with 3 files: index.html, style CSS and script.js. In index.html, we link style CSS file and JavaScript file and create div with a class of floor and HTML5 canvas element with an ID of canvas. In style CSS, we use asterisk selector to target all elements on the page and set box sizing to border box. This means that border and padding will be included in element's total width and height. Div with a class of floor will hold our floor texture. There is a better way to generate textures for our games, but for this project we will use CSS. I set it to position absolute, width 100%, height 100%, background blue for now, top and left will be 0. I will go to opengameart.org and download some nice floor textures, link in the video description. You can just download it by clicking here and unpack it to your project folder. Now I will link it, replacing blue with URL attribute, and I pass it the path to my image. For you, the path might be slightly different depending on how you name your floor textures folder. I will give it transform rotate 50 degrees, which rotates the element like this. There is a better way to do this with just CSS. I will use CSS3 transform property you might not know, called rotate 3D. It expects 4 attributes: X, Y, Z axis and angle you want to rotate. The first attribute stands for X axis. If you put 1 here, it will rotate X axis by the angle you pass as the 4th attribute. If you put 0, X axis will not be rotated. The same applies for the second argument for Y axis and the third argument for Z axis. I will pass it 1, 0, 1 to rotate X and Z axis, and 50 degrees for example. We get this nice angle. To make the floor cover the entire screen, I make it much larger. Width and height will be 500% and I offset it a bit. Top minus 200%, left minus 200%. This will do for now. We will get back to this. Canvas will have position absolute, top 0, left 0, width 100%, height 100%. We are done with HTML and CSS, everything else will be done with JavaScript and script.js file. Let's grab hold of our canvas element with JavaScript. I target the canvas element with getElementById and I save it in a constant variable I call canvas. CTX, shortcut for context, is equal to canvas getContext2D. This will give us access to built-in drawing API, and now we can call our CTX variable, which holds many built-in canvas methods used for drawing shapes, text, images, and other objects. We set canvas width to window inner width and canvas height to window inner height. We will load our image. I create an object that will hold all our images. Constant variable images equals to empty object. Then I do images.player equals new image, which will add player image object inside our images. I set its source like this: images player src equals image path. This is where we put our sprite sheet for the player character. I found this nice sprite sheet online. One good thing about it is that it doesn't only have up, right and down walking animations, but also diagonal, upright and down right. This way we can make the character walk in many directions. I reference the PNG file I just downloaded here, and I will declare a couple of variables that will allow us to navigate and find the frame we need within the sprite sheet. I will create variables called player width and player height. I open my sprite sheet and I see the file is 1649 pixels wide, and I count the columns. This sprite has 16 images per row, so I divide 1649 divided by 16. to get width of 1 frame. I will use all decimal points for precision, why not? Height of the sprite sheet is 905 pixels and it has 8 rows, so height of 1 frame is 905 divided by 8, which is 113.125 pixels. We will go from frame to frame by using X and Y coordinates. Player frame X will be what frame are we on horizontally. I will do frame 3 for now because that's where the walking animation starts. Player frame Y, or the horizontal coordinate of the first frame, will be 3 as well. We need to count from 0 here, so 0, 1, 2, 3. It will make sense when you see how we calculate the coordinates in a minute. Player frame Y equals to 3 will skip to this row in the sprite sheet, so we will animate our character walking to the right. I will also create variables called player X and player Y. These will determine at what coordinates we draw our player on the canvas. Don't get confused here. Player frame X is the coordinate of frame to draw within the sprite sheet. Player X is where to draw that frame on canvas. We will also declare player speed. Let's set it to 6 for now. Now we want to take our sprite sheet, choose coordinates of a frame, and draw that frame on canvas. To make it reusable for other sprite sheets in our game, and so that we can customize it if needed, I will wrap it in a custom function I call, for example, drawSprite. This function will expect 9 attributes. Let's just write them down and I will explain it in detail in a minute. This is the most important part of sprite animation with JavaScript, guys. Feel free to make notes if you think you need to. The attributes we pass it will be image, sx, sy, sw, sh, and dx, dy, dw, dh. There is actually a very simple logic to this. To see what all these attributes mean, we go inside our custom function and we call our context ctx, which has access to all 2D Canvas API drawing methods. And we call built-in drawImage method. The only purpose of this method is to draw image onto the canvas. What you might not know is that this method has 3 different versions. We will need a third longest version. If you look at it, it expects 9 attributes. The first one is the image we want to draw, in this case our sprite sheet. The next 4 attributes specify area from the source image we want to draw, source X, source Y, source width, and source height. And the last 4 attributes we pass to it will determine where on the canvas the image will be drawn and how big it will be. Destination X, destination Y, destination width, and destination height. So, inside our custom drawSprite function, we call ctx drawImage and pass it the same attributes sx source X, sy, sw, sh, dx or destination X, dy, dw, dh, destination height. Now we can call our drawSprite function anytime and pass it 9 attributes to draw 1 frame from our sprite sheet. Basically, all that these 9 attributes mean is give me an image, give me 4 numbers to know what area to crop from the source image, and give me 4 numbers to know what area on destination canvas should I place the cropped image onto. Let's create animation loop. All the code in here will run over and over for every frame of animation. First, we will clear the entire canvas using clearRect method. Now we will use drawSprite to draw our image onto the canvas. As the first attribute, we pass it the sprite sheet, so images.player.src from line 9. The next 4 attributes we pass will determine what area we want to crop from our original sprite sheet to show only 1 frame. Sx is the x-axis coordinate of the top left corner of the subrectangle of the source image. We will calculate it by saying player width times player frame X. You remember how I said that frame X has to start from 0? That's because to crop out the first image, we need to do player width times 0, which equals to 0. So that's why we need to start from 0, because we start cropping from the left edge, so 0 pixels, along the horizontal x-axis. Same idea for player frame Y. Sy, which is the y-axis coordinate of the top left corner of the subrectangle of the source image, will be player height times player frame Y, starting at 0. Source width will be player width, we already calculated. It's the width of one frame. Source height will be player height. So here, we specified where to crop one frame from source sprite sheet file. The next 4 values will determine coordinates and size where on the destination canvas the image will be drawn. This part is very simple. dx coordinate will be player x, dy coordinate will be player y, dw will be player width, and dh will be player height. Now, when the window has fully loaded, we can call setInterval. If I use request animation frame, the animation will run too fast. There is a technique to make sure our frame rate is actual frames per second, regardless of which machine you run the code on. We go through that in some other video. For now, let's just do setInterval and call animate 30 times per second. There we go, we managed to draw a frame from our sprite sheet with coordinates 3, 3 onto the canvas. And since our setInterval is running, the same image is actually being redrawn over and over. Now we need to learn how to move it. Before we do that, there is a small issue. As usual, when working with canvas, if the user decides to resize canvas after it has been loaded, everything on the canvas stretches. It can be fixed easily by using add-event-listener for resize event, and in callback function, every time resize event occurs on browser window, we set canvas height to window inner height and canvas width to window inner width. No stretching anymore. So we have 2 variables. Player frame x, which determines which column is the frame we crop out from our sprite sheet on, and we have player frame y, which determines the row. The way this particular sprite sheet is organized, you can see that if we switch to the top row, row 0, we will get animation of our character walking up. In the animate function, I will create an if statement. You can also notice that the first line of the sprite sheet has 16 animation frames, and for example this row with our character walking right has only 14 frames. Also, the first 3 frames are just idle animation. Walking animation starts on the 4th column. And since we said we have to count from 0 to be able to draw the correct frame, that would be a frame 3. 0, 1, 2, 3. I want to start with animating our character walking to the right. We have 14 animation frames on that row, and we start counting from 0. So if player frame x is less than 13, player frame x plus plus. This will add +1 to the player frame x variable for each frame of animation. Else, player frame x is equal to frame 4, which is the beginning of walking right animation. Actually, let's do 3, frame 3. I'm not exactly sure how this frame will look if we include it in the movement. Let's see. Looks alright. Let's also move the character. Variables player x and player y determine where on the canvas character is drawn. I can say if player x is less than canvas width plus player width, to make sure our character has walked past the right edge of the screen, player x plus equals player speed. We will add value of variable player speed we declared on line 17 to the player's position on the x-axis for each frame of animation. Now he just walked away. We need to reset it, so I say else player x is equal to 0 minus player width. When the character walks past the right edge of canvas, we will reset it and hide it just before the left edge of canvas. Well, this doesn't look like he's coming back. Come back, where are you? I made a mistake somewhere, let's see. Oh, player width and player height are numbers, but when I put them in parentheses like this, they are treated as strings. Will he reset now? Yes. Well done. You managed to animate Sprite Sheet and make it walk endlessly across the screen. There is one issue here with the way I implemented background image. By the way, this is not how you draw a background for games. There are much better techniques and we will go through these later. To fix our CSS background for now, all I have to do is give body element width 100%, height 100%, and overflow hidden. This will hide scroll bars. Okay, back to coding. We animated this row on our sprite sheet. What do we do if we want to make our character walk up instead? I will go up to our global variables and I will create an array. This will hold a couple of strings, each representing one animation row from the sprite sheet. Up, top right, right, down, and jump. We don't just want to animate one character, we want to have full screen crawling with characters walking in random directions. To do that, we will use a JavaScript ES6 class. You can use these when you want to create many similar objects. In this case, each object will be one character. When I say similar, it means all characters will have shared properties and methods. Same size, and will be drawn from the same sprite sheet, but some of these properties will have randomized values, like player speed and their x and y coordinates. Let's do it. Each JavaScript class has one mandatory method called a constructor. Constructor will run just once per object at the moment when we create that object, calling the new keyword. More on that in a second. All that the constructor does is it creates a new instance of character object, assigning values to properties on that object. If we pass a range of numbers with math random to certain property, each instance of that object, each of our characters, will have randomized value for that property. Let me show you. Inside constructor, we use this keyword. All it means is that we are telling the constructor with property on this particular instance of character object you are creating right now is 103.0625. I'm taking the value from line 20, by the way. We will convert all of the global player variables into properties on character class constructor. These big words might sound confusing if you are a beginner, but it's actually very simple once you've done it a couple of times. Don't worry, it will all make sense. This.height is 113.125. We already calculated that earlier. This.frameX is 3. This.framey is 3. We will randomize this later as framey values determines which row we are on in the sprite sheet and therefore it determines direction of animation, up, right, and so on. This.x equals 0. This.y is 0. These values are coordinates where the character is drawn on the first load before it starts moving. This.speed will be a random number between 3.5 and 5. I want each character we create to walk slightly different speed. Now I can comment out all these values as we replace them with JavaScript class. I will go up to our global variables and create an empty array called characters. I call built-in push method that takes whatever we pass to it in parentheses and pushes that to the end of characters array. In parentheses, I pass it the new keyword followed by class name we created, new character. New keyword will just call the constructor method on JavaScript class and creates one new instance of an object based on the template we provided inside the constructor. At the same time, this object will, due to inheritance, have access to all methods on the class. We haven't created any methods on our character class yet, but we will. So I created one instance of the character class and I pushed it into characters array I created. Ignore the animation on the right side, it's only there because I haven't refreshed the page. To get this to animate, we have to do one more thing. I go inside the character class and after closing parentheses of constructor method, I create a custom method. I will call it draw, for example. Now I go down to animation loop and I comment out all this code that is responsible for drawing and navigating within Sprite Sheet. I also copy all that code and I paste it inside draw method on character class. You can see I'm referencing all the global variables. I will have to slightly rename these to make sure these values are taken from character object I created and pushed into characters array. I'm using VS Code editor, so I can just highlight any text, and when I hold down Ctrl, every time I tab D, it will highlight the next instance of that text. I highlight all references to player and I replace them with this dot. JavaScript is case sensitive, so I also have to change uppercase characters to lowercase to match the variable names. I will go up to the constructor and add one more property called this.action. This will determine which direction our character is walking. Let's do up for now. I create a new custom method on characters class. Let's call it update, for example. I go down to animation loop and I comment out all this code. I also copy it and paste it into the update method. Again, in VS Code, I hold Ctrl and tab D a couple of times to highlight instances of player and replace it with this dot. And I change capital letters to lowercase. Like this. Now we have custom draw and update method on our character class. Every character object created by character class constructor will have access to these two methods. Let's change this dot action to write. And I will wrap all this code inside update method in an if statement. If statement that checks value of this dot action. If this dot action is triple equal means we check both variable type and value. If it's triple equal to write, run code inside this if statement. So here we created empty characters array, and here we pushed one new instance of character object into it. This object holds all data about one character. I can delete all this code from animation loop and I can replace it by calling draw method on the first object in characters array. Arrays start from 0, by the way, not 1. So I call the draw method we just created. This method is responsible for drawing on canvas and navigating within Sprite Sheet. I will also call update method, which currently checks if character action is equal to right, and if so, it will animate our character walking to the right. So by typing characters square brackets 0.draw, I am referencing data we pushed into array from line 11 using our JavaScript class. Each object we created this way has access to its class's custom methods. I can also delete these variables, we won't need these anymore. And I forgot about one thing. Classes cannot be hoisted the same way functions can, so I cannot actually call class constructor here before I declare it. I need to make sure I call it after I declare it. Like this. Yes, we are animating again. We have successfully converted a set of global variables into a reusable JavaScript class, so now we can start making copies of our character. That's what JavaScript classes are for. You create a blueprint and you use that blueprint to create multiple similar objects. In this case, the class will create data objects using its constructor method and push them into characters array. Each of these data objects will represent and hold data for each of randomized characters we create. Are you still with me? There is source code linked to CodePen for the final product available in the video description, by the way. What now? What now? So I guess now we want to try and make our character walk in different directions. But before, let's just randomize y coordinate. When the character walks off the right edge of the screen, I don't want it just to take the same path. I want it to spawn at a different location along the vertical y-axis. So here in the else statement, where we reset character after it walks past the edge, I will also set its y property to be a random number between 0 and canvas height minus character size to make sure it doesn't spawn too low. It doesn't work, huh? Oh, it's actually this.height. Yes, it works. So here we have an array called character actions. I want our class constructor to randomly pick one of these values and assign it to this.action property for each character we create. Let me create another copy. I will first create version of this array with less options. And inside class constructor, which runs only once per object it creates, this.action will be assigned value from character actions array. So if I say 0 here, this will be up. The first value from character actions array. 1 will refer to top right and 2 will refer to right. To randomize this, I call mathRandom times character actions.length. This will result in number with decimal points, which will not work here, so I need to wrap it in math.floor, which returns the largest integer less than or equal to a given number, so basically it will round down the decimal points. Now, each time we call class constructor, this.action on character object will be a random number from character actions array. So I go down to the update method, and here where we check if character actions is equal to right, I will do else if statement and check if this.action is equal to up. If it is, we enter the code block, and here another if statement. This will check if this.x or the position of the character along the horizontal x-axis is less than 0 minus this.height. If it is, this.y is equal to canvas height, so all the way down, plus this.height to hide the character below the bottom edge of the screen. Also, this.x will be randomized, so the character doesn't walk the same path over and over. Else, meaning our character hasn't walked off the screen yet, just push it up by reducing its y position by the value of its speed for each frame. Let me just swap these statements around so it's consistent. I want the first if statement to be reset check, and the else statement to be move animation. Bear with me, please. I will also remove this option from actions array just for a second. So now we have only two options, up and right. I made a mistake somewhere. It's character action. So now I refresh. Yes, it moves up, but it doesn't reset. Why? Oh, because here I need to check position on the y-axis, not x-axis. Yes, here we go, perfect. I will create a global variable called number of characters and set it to 10. Here, where we call JavaScript class constructor to create instance of character class and push it inside characters array, I create a for loop. This loop will run 10 times, that's what we set number of characters variable to. So I put this code inside here and we create 10 randomized characters. In animation loop, I will cycle through characters array. We just push 10 objects into it. For each of these objects, call draw and update on them. Yes, like this. For the characters that are moving upwards, we also want the frames to come from the first row of the sprite sheet. So in class constructor, I remove frame y, which determines row in sprite sheet, and I place it after we assign value to this.action. Here I can check if this.action is up, this.frame y is 3. Else if this.action is right, this.frame y is actually 3, belongs here, and up animation is the first row, so 0. Now we have randomized characters moving up and right. Let me just change the movement speed. Let's try one more. If this.action is a jump, this.frame y is the last row, so 7. I also add jump as one of the options here. You can see the jump animation is blinking. We will fix that, but first, I don't like how they walk in formation when I reload the page. Let's make the initial X and Y position a random number. Much better. The reason that jump animation is blinking is that I'm animating between frames 4 and 13 on the horizontal X-axis, but on the sprite sheet, the jump animation actually happens between frames 0 and 9. So I fixed jump animation, but now the walking animation is not playing all its frames. I'll slow it down so you can see. Let's change this loop to rotate between max frame and min frame variable instead. And inside constructor, I can set min frame and max frame different for each row of sprites. I will copy it like this. And up animation starts at frame 4. And ends at frame 12. Sorry, it actually ends at frame 15 because we count from 0. Because the frame is cropped from the sprite sheet from the top left corner. Right. Right is between 3 and 13. And jump is between frames 0 and 9. So now we will animate between min frame and max frame, which is different for each row. And it works. Let's try one that's moving diagonally, for example down right. Another else if statement. Let's do row 4, and it starts on frame 4 and ends on frame 15. So we have animation now, but we also need to make them move in the correct direction. Inside update method, if this.action is equal to down right, in else statement we increment both X and Y position. Yes, it's actually walking down right. And in the reset check, we check if this.y is more than... I'm struggling here, bear with me. We check if this.y is more than canvas height plus this.height and double ampersand. At the same time, if this.x is more than this.width plus canvas width. Basically, I check if the character has walked past the edge along both horizontal and vertical axes. Yes, it's resetting now. I will add all the other directions the same way we just did, and I will release the full source code on my CodePen in case you are coding alone and you want to compare it. Source code in the video description. Yay, we are done. Hope you had fun coding with me today. Don't forget to click the like and also click the bell icon if you want to be notified when I release the next episode. Also, while you're here, check out my vanilla JavaScript creative coding series or CSS experiments playlist. See you later.